By the end of this episode, you'll have written real Go code, understood every line of it, built a binary from it, and set up a proper Go module, the foundation every Go project starts from. Let's write some Go. Open your terminal, create a directory, and create a file called main.go. 6 lines. But there's a lot packed in here, so let's go through each part. Package main. Every Go source file must declare which package it belongs to. The main package is special. It's the signal to the Go toolchain that this file is an executable program, not a library. Only package main files get compiled into runnable binaries. Import FMT. This imports the FMT package from Go's standard library. FMT stands for format and gives us functions for printing and string formatting. Go's import system is explicit. If you import a package and don't use it, your code won't compile. That strictness exists to prevent bloat and to keep codebases clean. Func main. This is the entry point. When you run a Go program, execution starts here in main. There are no classes, no objects, just a function. The name main in the main package is special and required. Rename it and your program won't know where to start. FMT. Println. Calls the println function from the FMT package. The capital P matters in Go. Exported identifiers, functions, types, variables that are visible outside their package always start with a capital letter. Println is exported from FMT and available to us here. There are 2 ways to execute your program. First, Go run. This compiles and runs in a single step. The binary is temporary. It lives for the duration of the run and is then discarded. This is what you use during development. It's fast and convenient. Second, Go build. This compiles and produces a permanent binary on disk. On macOS and Linux, the output is a native executable. On Windows, a.exe file. This is what you use when you're ready to ship or deploy something. One thing that makes Go particularly nice for deployment. The binary is self-contained. No runtime to install, no shared libraries to manage, no virtual machine. You compile once and copy the single binary to any machine with the same OS and architecture, and it just works. And Go's cross-compilation is genuinely easy. 2 environment variables. That's it. You can build a Linux binary from your Mac without any extra tools. Let's write something slightly richer to preview features we'll cover in detail soon. Notice a few things. We're importing 2 packages using a grouped import. The equals operator declares and assigns a variable in one step. We'll cover this in depth in episode 6. FMT. Printf formats output using verbs like %s for strings and %d for integers. And the for loop. Go has only one loop construct, no while, no for each. We'll cover all of this soon. For now, run it and see what you get. Now let's talk about Go modules. One of the most important concepts to understand before you write any real Go code. A module is simply a collection of Go packages with a declared identity. Every Go project starts with a go.mod file, created by running. The module path is typically a URL-shaped identifier. It doesn't have to be a real URL, but using your GitHub username and project name is the convention. This path is what other modules use to import your code. After running Go mod init, you get a go.mod file that looks like this. 2 fields. The module path and the minimum Go version required. That's it for a fresh project. When you add external dependencies, go.mod grows. The standard way to add a dependency. Go get downloads the package and adds it to go.mod. Go.mod tidy cleans up. It removes unused dependencies and adds any that are imported but not yet recorded. Run go.mod tidy before every commit. It's good hygiene. Alongside go.mod, you'll see a go.sum file. This contains cryptographic checksums of every dependency. You never edit it directly. You always commit it to version control. It's what guarantees that anyone who checks out your project and runs go.mod tidy gets exactly the same dependency versions as you, byte for byte. This is Go's reproducible build story, and it works. Let's build a minimal multi-package project to see how modules and packages fit together. The math package? Notice? Package math, not package main. This is a library package. The The function add starts with a capital letter, so it's exported and visible to other packages. Main.go imports it using the full module path. Run it with go run main.go and you get 10 plus 5 is equal to 15. 2 files, 2 packages, 1 module. This is the pattern that scales up to projects with hundreds of packages. In this episode, you wrote your first Go program, understood every line of it, and learned the 2 ways to run it. You know that Go run is for development, Go build produces a permanent self-contained binary, and cross-compilation is just 2 environment variables. You know that every Go project is a module. Go.mod defines its identity and dependencies, and Go.sum guarantees reproducible builds. In episode 5, we look at how Go organizes code into packages and how the import system works, building the mental model you'll use for the rest of the series. See you there.